All right, so 16 more exponent derivatives, these are log derivatives now. So y equals the ln of x, and that whole thing squared. So the derivative of, where are these? I have them written somewhere. Perhaps. There it is. So the derivative of the ln of x is 1 over x. The derivative of this would be basically, we're going to treat this like a chain rule. So we're going to take the derivative of the outside. So we're going to pretend that this is just like, say, an x in here. So that would be 2 ln of x for that part. Times the derivative of the inside. So the derivative of ln of x is 1 over x. So then we could rewrite this as 2 ln of x over x. That was impressive.
It felt pretty good.
I've had like a headache all day, and I've like popped my neck a couple times.
That's the best feeling. The pressure.
Yeah. I think it's because I sneezed the other day and pulled something in my back. I sneezed like 5 times in a row. It wasn't just one singular sneeze, in case anybody was wondering. And I like pulled something in my upper back, and so like I've just been like super like stiff, I feel like. So I was trying to just like relax. Yeah.
Also, Josh was like laying around his pencil, and I just found a giant piece of lead on me.
Yeah.
I was like, what? I thought it was a hair. Or
I hit my
something.
target.
That's funny.
Whatever.
All right, so with one like this, I would suggest that we rewrite 10 over x as 10 times x to the negative 1, just for the sake of when we do our chain rule, it'll be easier to deal with. So ln of 10x to the negative 1. So the derivative of the ln of x is 1 over x. The derivative of the ln of u, which 10 minus x to the negative 1 would be u, is 1 over whatever's inside the parentheses, and then times the derivative of whatever's inside. So this would be 1 over all this stuff in here, so 10x to the negative 1, times the derivative of in here, what would the derivative of this stuff in here be?
Negative 10x to the negative 2.
Yep. So then, keep in mind this is like all over 1. So this 10 and this 10 cancel. I have an x to the negative 1 and an x to the negative 2 up here, so what do I need to do?
Like flip their spots. Or like.
Well, I want to write them as one thing, if I can. Any ideas how I would do
You could
that?
like move one of them to either the top or the bottom and like subtract them or whatever.
Well, so when we change the sign, we want to add them. But I would suggest you take the bigger negative 1 and move it opposite of wherever it is, because we don't want a negative exponent. So if you move the bottom one to the top right now, you're going to have to move it back to the bottom. If we move top to bottom, then it'll get rid of it. So this is going to become 1 over, well, negative, don't forget the negative. We canceled the 10s, but not the negative. So this would be x to the negative 1 plus 2, so x to the 1, so just x. So negative 1 over x is what that one ends up being.
So I think I might have missed whatever you said on the at the very beginning of that problem. But, so where did the ln go?
There's just not an ln in these.
Okay.
The derivative of the ln of x is 1 over x.
Okay.
The derivative of the ln of u is 1 over u times the derivative of u.
Okay.
So it just goes away. In the derivative of like log base a of x, though, that's different.
Okay.
Which is probably what we're, well, not the next one, but one of the ones that we're doing shortly. 20y equals x ln of x minus x.
Hi, I'm back. Do you care if I remark these with basketball numbers?
No, I don't care.
Okay. Do you have a Sharpie that will wash off easily later if I wash them tonight? Because I know the gold one did not come off last year.
I don't really know.
I can't remember which one we had beforehand that came off really easy. It might have been the silver
I
one.
was thinking silver. Although I don't have a gold one, so this is the gold one.
Yeah.
I don't know. I would just say try silver.
Yeah.
We'll figure it out. I'm sure with like alcohol or something I can get it off.
Yeah.
All right. Any I was going to say that really strong one probably will work. Both of those are really strong. What is this? So what do I get when I do that?
ln of x plus 1 minus 1.
So you did the derivative of the first times the second plus the first times the derivative of that, right? Which is 1 over x. So that's where you're getting the 1 from. You just already did it. Minus 1. So x's cancel. So you have ln of x plus 1 minus 1. So this ends up just being ln of x. All right, the next ones are the ones that get a little bit weird. So the derivative of log base a of x is 1 over x ln of a. So y equals log base 5 of the square root of x. So probably easiest to think about this as log base 5 of x to the 1/2. So this is basically the chain rule of this. I'm going to write this one because this one's always the one that I feel like people, including myself, struggle with the most, is 1 over u ln of a, which a is the base, times du dx. So u is this stuff that's in here. So this is going to be 1 over x to the 1/2 times the ln of the base, so ln of 5, times the derivative of u. What's the derivative of x to the 1/2?
1/2 x to the negative 1/2.
So when I do this, moving this stuff around, this 2 is going to end up on the bottom. I'm going to have x to the 1/2 plus 1/2, which is going to be what?
X to the 0 or 1.
X to the 1.
Yeah.
I was like 0.
Yeah, I am.
So this is going to be 1 over 2 x ln 5.
Not for sure the x is just going to disappear.
Josh wanted it to just go poof and be gone.
And then we could actually have a real number for answer.
How'd you get it was x to the 9 again?
So the step in here, basically on the bottom, I ended up with x to the 1/2 plus 1/2 because I moved this one to the bottom.
Okay.
So I basically ended up with, well, this is what I technically did. X to the 1/2 times x to the 1/2.
Okay.
And then the 2 and the ln of 5 on the bottom as well.
Okay.
And then the last one we have y equals 1 over log base 2 of x. I would say probably the easiest way to deal with this one is to think about this as a quotient rule, so that you make sure you get all the signs right, because this one is kind of a weird one. So derivative of the top is 0 times the bottom, so I'm just going to write 0 as a placeholder, minus the top, which is 1, times the derivative of the bottom. So the derivative of the bottom is x times the ln of 2. So that's whatever's inside times the ln of whatever the base is on it, over the denominator squared, so log base 2 of x squared. Is that working?
I found rubbing alcohol,
Oh,
so I feel like that might work better.
it should, hopefully.
Fingers crossed.
Just try not to get the mouthpiece.
Yeah. It'd be really nasty.
So just
You
don't
can always
make
rinse
the
them off
square.
downstairs
Oh yeah.
after.
All right.
There's
so
a
now
sink
it
down
doesn't
there.
I like how you think.
So
It's not
would, so on the top, shouldn't that be 1 over x ln 2?
Yes, I was just getting ready to fix that.
Yeah.
I was looking at it, I was like, wait a minute, something's not right.
I even wrote to one, and I was like,
Because I was like, I know it has to move to the bottom, and then I was like, oh wait, that's because I wrote it wrong, because it's 1 over x ln of a.
did that count as a combination?
Maybe.
Maybe.
So then this stuff, making it all 1, would be negative 1 over x ln of 2 times log base 2 of x squared. And as ugly as that looks, that is the answer. I mean, technically ln of 2 is just a number. So, but we just leave it like this. Like, we don't go through and like multiply it or whatever.
How did you get that on the bottom then, or like the fraction on top?
Well, technically this is just negative 1 over x ln of 2 times 1 over log base 2 of x squared. I just wrote it all as one thing.
Okay.
Alright, so that's it. So basically, what I normally do is say to go through and do every odd one of these just for practice, because they are pretty easy, but just getting familiar with using them. So I usually say 1 through 25 odd on these. If you feel like you don't need to do that many, that's fine. But just personal recommendation there. Also, if y'all want to do some of them now and then just finish them up on Monday, like Monday's going to be a review day for a quiz on Tuesday, so if you need to finish them up, then you can. If you want to just take them home and finish them tonight and be done and then not have to worry about them, that's fine too. I don't care.